Hello, welcome to another recorded webinar from Oslo. My name is Miki Markovic, and I'm the VP Professional Services at Oslo. Today, I'm going to review with you the Open to Secure Custom Key Management by Oslo. On today's agenda, I will do a market overview. I will explain about the secure credential, how to manage a custom key, how to use the ASB01 together with the CPR27 card programmer, and how to create a configuration and user cards on ASB01 together with the CPR27. Let's start. Let's start with the market overview. Most common technology in the market are still based 125 kHz solution, like HID, EM, and TEMIC solutions using ASK, FSK protocols to read information from the card. On the last 8 years, 9 years, we can see that the market is starting to shift into smart card solution. This is based on higher frequency of 13.56 megahertz. The 13.56 megahertz is usually referred as smart card solution, and the main reason for it is this technology is mainly used for credit card and public transportation, etc. For today, also NFC solution with phone payments are also using 1356. Most of the access control application in the market today, especially in the mid-low level, are using a CSN reading. It's actually reading the wireless chip serial number, CSN card serial number of the card, and doesn't use any advantage of the secure solution of reading secure data from the card storage. So if we would try to look at the security level, we can see that we have the lowest level is magnetic stripe, very easy to copy. Above it, we have the MIFARE CSN. Above it, we have the 125 kilohertz frequency, EM, TEMIC, HID, MIFARE Classic, and DeskFire for the secure solution. And under DeskFire, we can talk about other solutions like iClass AC, Calypso, and similar solutions that use secure encrypted data. So as I just mentioned, there are multiple solutions based on the higher frequency of 13.56 megahertz, such as the MIFARE family, the NFC, Felicia, iCard, payment, credit cards, etc. All of the above solutions can be used as a secure solution to protect the data stored on the card. Access control application mainly use a simple way called CSN, card serial number of or UID. UID stands for unique ID of the serial number. 13.56 megahertz for access control. As we can see, there are two common uses for 13.56 megahertz technology for access control platform. The non-secure solution. Readers can read the public ID, CSN, UID, non-ID of the credential. ID can be read by any NFC device like Android phones and can be easily duplicated. From the security point of view, it's similar or less than 125 kilohertz solution as we saw earlier. As a secure solution, the data is stored in secure location on the card. Only if there is a match between the reader and the card, the data can be accessed and read. Such solution is being used for payments, e-password, transportation, and more. And there is a few security levels that can be achieved. The secure solution. So a little bit of history about the 1356. The 13.56 megahertz solutions was originally created for public transportation services. And in the same time, They addressed the security issues of 125 kilohertz that easy to duplicate and creating a two-way communication between the card and the reader. On mainly transportation services, you can charge your card with amount of money, and once you are getting on the bus, the sum will be deducted. This is a two-way communication between the card and the reader, creating some kind of a virtual wallet. This is the integration of card encryption and ability to store data on the card. So when going to higher frequency, we can move more data, and we can have also a higher level of security of the data. The secure solution, the higher of secure solution, or the method of secure solution is dependent on the card technology. There are a few levels. I'm going to mention two of them. One of them is managed access by keys to the data stores. And the other one is full encryption of the data and full encryption of the communication. So there is the data encryption, there is communication encryption, and there is data access. This is the few levels of security that can be achieved using a secure solution on a 13.56 frequency. What do we offer in Rossler as a secure solution? So also, we offer a few levels of secure solution for credentials and cards as MIFARE Classic sector. You store your card in a specific sector and block with access key to the sector. The access key is a 12 hex characters, so it's 6 bytes. And it's called a key A access. Once there is a match between the key, the sector, and the offset, we can get the data from the card. MIFARE Plus sector. Encrypted data is stored in a single block on the sector and protected by 16 byte. It's 128 AES, 128-bit AES encryption, and is stored in a secure access with encryption. So the data is encrypted, and the access key is high security 128-bit, and all the encryption is handled by a single hardware. MIFARE DeskFire. Encrypted data is stored in a single file attached to application ID and protected by 128-bit AES key. All encryptions, so communication encryption, data reading encryption, data storing encryption, is handled by external hardware called SAM, Secure Access Module. This is a hardware module from NXP. NXP is the manufacturer of MIFARE. And all this hardware does, there is a SAM module on the card, there is a SAM module on the reader, and all this module does is in charge of data reading, data encryption on the communication. So this is an end-to-end encryption from the data stored on the card until the data gets out from the reader. And if you're using Rossler O2S DeskFire readers, you can get also data encryption to the control panel and from the control panel to the server using the OSDP v2 secure channel. But this is for another webinar. So what do we offer with a custom key? Until now, Rossler secure solution, the open to secure solution was only enable configuration for MIFARE Classic. So you can only configure your own keys and security on MIFARE Classic. Now, with the outcome of the new firmware and software tools, we offer you the possibility to configure your own key also for DeskFire. Using a CPR27 and an updated version of the ASP01, you can fully program the O2S DeskFire reader, which AYX6680 readers. How does it work? How does DeskFire work? So just let me get the pointer. And what we see here, we have a reader and we have an open to secure card or custom key card. It doesn't matter as long as there is a match. What's happened is the reader asks the card, do you have this application ID? The card answers yes. Then we get an encryption key. If we pass the encryption, then we get access to the file. The SAM is doing all the encryption of the data, transfer encryption data back to the reader, and send the data to the reader. All this application of the communication is managed by the SAM. So everything is encrypted. We have identification of the application ID. We have authentication using encryption key. We have access to the file and read data from the file. The way this file is managed, unlike MIFARE Classic or MIFARE Purus, is that each data we want to store on the card must be attached to an application and saved in a file. Data file size can be managed, and application ID can be anything in a 6-byte form. What is the ASP01 software tool? The ASP01 software tool is a software application that allows you programming and configure user card and configuration card for DeskFire. You can program everything from the MIFARE Classic solution to the DeskFire solution using one single software application. Regarding the DeskFire, we allow you to create DeskFire user card, MIFARE Classic user card, DeskFire user ID, read DeskFire user ID, read MIFARE Classic user ID, and create a configuration card for also DeskFire AutoOS videos. The CPR27 is a desktop programmer, USB powered. It's used to program any solution on the MIFARE DeskFire and MIFARE Classic. You can easily program whatever you like on your site, and it's a USB connected with a simple driver installation, plug and play. What can be set? So if we are looking on MIFARE DeskFire, we can define our own application ID in the range of 3 bytes in number. We can set our own application file, and we can use our own 128-bit ASCII. If we want to use a MIFARE Classic sectoid, so we can define the sector, the block, the offset, and the key to access the sector. The key is per sector and not per the whole card. General settings that can be set. We can set the figure format, reader setting, and keypad settings. And now I'm going to show you how it's works. Okay, I point my camera into the CPR27. The CPR27 is connected to my PC, and let's launch the ASP01. Make sure you are using the ASP01 version 2.0.0 and above. The latest release is 2.0.0.4, and please follow our website for any updates of the ASP01 software tool. Log into the ASP01 using the default password is admin, and we have a screen opening. This is the main screen. What's happened on the boot? The ASP01 will try to identify if CPR26 or 27 is connected. If not, we will have two tabs. One is the sector reader, the other is CPR27. We will go to the CPR27 and we'll see that the CPR27 is connected. What we have on the screen, we have the operation type. We can select between create DeskFire user card, create MIFARE Classic user card, read DeskFire user ID from a DeskFire card, read MIFARE Classic user ID from a MIFARE Classic sector card, and we create a DeskFire configuration card. Let's see the options under each option. So if we want to create a DeskFire user card, we need to assign the application ID number, the file number that should be saved. So application ID number, we have the max ID of 3 bytes. This is the maximum number availability. File number can be from 0 to 31. Custom AES key and new AES key. So what you need to do if you are just creating a card, add a new AES key for the card. Let's talk about the AutoCAD programming. The AutoCAD programming options allow you to program cards in sequence. While every card you program will give you the option to program the next one, increasing the user card ID by 1. So it's always plus 1 of the card ID. And I will show you how it works, don't worry. For each format, we can get the different available features. So if it's Rigging 26, we have facility code, but you can also have a customized format and just select the formats between 26-bit and 96-bit of custom, or 128 bits if you want a very large ID for increased uniqueness. This is the supported format of the reader. For the MIFARE Classic sector, so all the formats, feature, AutoCAD, and user ID are exactly the same. And we can have the key A, sector, block, and byte. Sector is available per the card. Byte block is available again by the card and the sector number. For example, for MIFARE Classic 4K cards, we have on sector 31 and 40, we have 15 blocks, and all the other sector, we have only 3 blocks. And byte is the byte offset, so each block has 16 bytes, and we can offset where to save the ID. Reading the cards, we just need to apply the AES key, the file number, the application ID, and same for the MIFARE, we need to set the access. If we like to create a DES file configuration card, so here we have some more options. And let's talk about first about the keys, about the secure solution, and then we drill down to the reader options. So on DESFire, we need to set the application ID, which we will use to store our user IDs. File number, same. It has to match the file number. Current AES key, new AES key. Current AES key, if we want to modify the key of the reader, we will use this current key. If it's a new reader, keep it as a default, all Fs. New key, if we want to use a test file, we must change the default key as a default key, telling the reader this technology is disabled and it will not read DESFire custom key cards. So we must change at least 1 byte of the selection. MIFARE the same. If we want to use a MIFARE Classic, we must change the key as the default key is not supported. We can set the sector, the block, and the byte, and the system will save you not to make any mistake. For example, sector 0, block 0 is not allowed as it's a manufacturer block, so you cannot set it and you will get a false if you try to program it. Host control for SDP. Host control means that the reader LED and buzzer will be only controlled by the control panel and will have no self-behavior. If you disable it, the reader will act with its own self-behavior and will ignore any command coming from the control panel. On general, we can have formats. We can reverse any format. We can allow reading roster authorized credentials. So if you would like to support also custom key and roster P-program cards at the factory, so you just need to mark the allow reading roster authorized credential, and the reader will support authorized credential as well. Output CSN fallback. Output CSN fallback means that if the reader cannot access the secure data on the card, it will output the card CSN as a fallback. The output card CSN always will output 32 bits. buzzer active, LED active. If we are not using OSDP or using OSDP host control off, we can disable or the LED and buzzer. By default, they are enabled. Keypad, if we are using a reader with a keypad, we can set the keypad format and the behavior of the backlight of the keypad. Let's create a simple configuration card. So I just place a card on the reader, and I will change the new key just for the there. I will make A0 for the key. The application ID, I will use 5544, and file number, I will take 24. I don't have a keypad here, and I don't want to use MyFair. That's fair only OSDP host control, and I will click start. If we have any issues, I will get the event here. So we have writing data DESFire configuration card success and data file success. If I will try to create a user card now, so let's go create MyFair user card. I will use the same new key. Let's just copy and keep it for reading cards. Same application ID and file number. I will do AutoCAD programming. And let's say 4 cards. We will do a fixed facility code of 127, and we start with 1000 for the ID. And I will click start. You can see that I now need to replace the card on the reader. I will replace the card and click yes. What's happened? We have user card 1001. So we have 1000 succeed, 1001 succeed. I will replace the card again and click OK. And again. And AutoCAD powering succeed. This means that I created 4 cards. Now, if I want to read the data from the card, just to make sure, I will change it. I will go to read DESFire user ID. Make sure I'm creating the correct key here, file number and application, and I click start. Second, I created a mistake. There's one here, and let's go again to read. Okay, read ID from card succeed, and I get the ID of the card. This is the latest. So this is the latest card I programmed. If I will change the format, I will get the ID in different formats. So this is the ID in 32 bits, the same ID I programmed in 26. So you need to know on which format you tag. How do I program a reader? To program the AutoS DESFire reader, you need to take your configuration card and place the configuration card 20 seconds after power up of the reader. You will have 20 seconds to present the configuration card. If the configuration card is correct, you will get a success sound. If the configuration card is failed, you will receive a failed sound. That's all. This was the live demo of the ASB01 and CPR27. So a small summary. We talk about the secure solution. We explain what is a secure solution. We did a market overview, and we reviewed the market, the ROSA offering, and how to use the ROSA offering. Thank you for watching this recorded webinar from Oslo. I was Miki Markovic. If you have any technical questions, you can contact us at support.rosasecurity.com or support@rosasecurity.com. You are always welcome to visit our website at rosasecurity.com. See you on the next webinar.